All right, this is Ubaid on behalf of Electronics, and in this video we'll be looking at exponential equations and functions. Okay, so when it comes to exponential equations, if you need to solve exponential equations, you will need to make sure that the base on both sides of the equal to sign are the same. Okay, so say for example you have 3x equals 81, okay, and you want to solve this exponential equation, okay, you will need to find the value for x. Now, in order for you to find the value of x, okay, you want to make sure that the base on the other side of the equal to sign is the same as this base over here, okay, which is 3. Okay, so we know that 3 times 3 is 9, times 3 is 27, times 3 is 81, which means 3 raised to 4, okay, will give me the same base as this base over here on the other side of the equal to sign. All right. So we know that since the base are the same, we can just go ahead and solve for x. So x will be 4. Okay. So you can do the same for this equation over here. So let's say 5x minus 1 equals 25. So we know that we need to make sure that the base is the same on both sides of the equal to sign. So let's say this will be 5 squared. Okay, so we know that x minus 1 equals 2. Okay, now that the base is the same, okay, we'll simply need to solve for the exponents. Okay, so when it comes to the exponents, you're solving for x. And to solve for x, this will be 2 plus 1, which is 3. All right. Okay, let's take another example. So for this example, you have 9 raised to 2 minus 3x minus 27 equals to 0. Okay, so 9 raised to 2 minus 3x minus, okay, let's make this 3 raised to 3 equals to 0. Okay, and this will become 3 squared. All raised to 2 minus 3x minus 3 raised to 3 equals to 0. Okay, which means to solve for exponents, you simply multiply all the exponents over here, whatever is inside the bracket with whatever is outside the bracket. So 2 times 2 is 4. Okay, minus 3 times 2 is 6, so 6x. Okay, minus 3 equals to 0. Okay, so we know that 4 minus 3, this will be 1. So minus 6x, okay, plus 1 equals to 0. So therefore, we know that x equals negative 1 over negative 6, which means your x will be equal to 1 over 6. Okay, so when it comes to real world applications or practical applications, let's look at this example over here. The population of a certain small town is growing according to the function p raised to t, or p at t rather, equals 12,500 into 1.02 raised to t, where t represents time in years since the last census. Use the function to figure out the number of years it will take for the population to grow to 25,000 people. So we know that P at T is 25,000 right away. Okay, this is your Y value, so to speak. Okay, so your Y value, okay, so your Y value, this is 25,000. This will be 25,000 over here. This equals, okay, 12,500. 12,500 into 1.02 raised to T. Okay, 1.02 raised to T. So now we have here is 1.02 raised to T equals 25,000 divided by 12,500. Okay, so this will be 250 divided by 125. Okay, so this will be 2. So 1.02 raised to t equals 2. All right, so now what you can do is use the log function. To use a log function, this will be t into log 1.02 equals log 2. So use the log function on both sides of the equal to sign. Okay, which means t will be equal to log 2 divided by log 1.02. Okay, we can use the scientific calculator to figure this one out. So 2 log, okay, divided by 1.02 log. Okay, this will be 35. So t equals 35. And to double check this answer, we can sub in this value into this function over here. So let's say, okay, this is f at t equals 12,500 into 1.02 all raised to 35. So 1.02 raised to 35 will be this figure over here, times this by 12,500 is roughly 25,000. Okay, so this will be equal to 25,000 approximately. Okay, and this is how you double check the answer. All right, so this is basically how you use exponential functions and equations. On behalf of Real Electronics, this is Obey. Have yourself a great day.